So now we're going to talk about the 3 different ways to graph quadratics. We're actually going to review the 3 different ways that we've just learned. We've learned vertex, standard, and factored form, or sometimes called x-intercept form. Okay, so we started off with vertex forms. This is where we talked about the shifts, how it opens, and any stretches or shrinks. And so we just go through the steps here. We're going to end step 1 and step 2. Remember I said could be switched, so here I just switched them. You can start by plotting the parent function, or you can start with the shifts. Remember the parent function, okay, is just going to be 0, 0, 1, 1, negative 1, 1, 2, and 4. It's always those are your parent function points. You're always going to start off by plotting those if you're going to be using this method in order to graph. So plot that. Then you're going to state the shift, how it opens, and then stretches and shrinks. Then, after you apply the parent function, you're going to apply the shifts. You're going to first do the stretches and shrinks. Okay, first do this, then apply the shifts. So first go through and do the stretches and shrinks. Okay, now sometimes you'll flip it first. So if you have a is negative, you might flip the graph over. Okay, so you might flip it down here and put the parent function down here, and then you might stretch it from here. It's always helpful to make the y values and then state the stretch or the shrink so that you can see what your y values will become, and then do the shift. So do this first and then apply it. So that's how you graph. That's just a quick reminder on how you do vertex form. The other way you can actually do it is that you can plot the vertex, and then you can plot the parent function off the new vertex. So here we go. If I'm talking about that, let's say that here's my graph, and we'll just take an example. And I'm going to say that my equation is y is equal to 2x minus 1 quantity squared plus 3. Okay? So what we can do with this instead is, instead of putting in the parent function, we can actually plot the vertex first. So my vertex here is 1, 3, right? So I go over 1 and up 3. And I plot that. But what I do is I make a new axis right there. Okay, so I can make a new axis and then plot my parent function off of this. So here is my new axis. And what I can do is I can just plot off of that. So there's 1 and 1. So I can go and plot my parent function. Would be right here. But I can plot my vertex, and then I go over 2 and up 4. And over 2 and up 4. Okay, so there's my parent function. So I can just do that now. Then I could do my stretch, but I plot my parent function, then I go through and do my stretch. So this is another option, and it all depends on if you want to use the new axis. Is it better or worse? I don't know, but I just want to give you that other option. The next form we talked about was vertex form. And what we need to, this is standard form. On vertex, we're going to find the vertex. We have to actually find it. And in order to do that, we have to use negative b over 2a. Okay? And standard form, I guess I should go through this. So vertex form, y is equal to a times x minus h quantity squared plus k, where h and k are the vertex. Okay? That's vertex form. Standard form, y equals ax squared plus bx plus c. Okay, so the first thing I have to do is I have to find the vertex. It is not given to me in the equation. Find the vertex. The way I do it is that the x-coordinate, use negative b over 2 to find the x-coordinate. Once you have the x-coordinate, you can plug it in to find the y-coordinate. Okay, so you're gonna use this to find the x, and then use the x-coordinate to find y. The y-coordinate of vertex. Okay, then you can draw on your axis of symmetry, because remember your axis of symmetry is x equals whatever the x-coordinate is, which is h. Okay, so that is your x-coordinate. That's your x-coordinate of your vertex. So I find my vertex. I can then take my axis of symmetry. I'm going to dot that in. Then you're going to plot the y-intercept. And remember, to find the y-intercept is always going to be what your constant is. There's our, sometimes it's also the vertex. We'll talk about that. But the y-intercept, to find the y-intercept, you can also just plug in 0 for x. If you forget that the constant is how you do it. and then you're going to graph the reflection point. So you plot y-intercept, and then you go across the axis of symmetry, and you plot the reflection point. Now to get that fifth point, you're just going to pick an x value. You can pick any x value you want to, but I would suggest something close to the axis of symmetry, because you don't want to get too far out there, because if your graph is right here, and here's your vertex, okay, you don't want to pick a point way over here, because that's not going to be too helpful. It might be way off the graph, too. So you want to pick it right around that axis of symmetry, okay? It can be, just within a couple, because otherwise it's going to start going off the graph pretty quickly. Okay, so pick an x value, find the y, and then graph that point and its reflection. Now, what happens if the y-intercept is the vertex? So, if I have a graph, and here is my vertex, well, that's also my y-intercept. So, what do? So, what you do here is you pick a point. Pick an x value. That is close to that axis of symmetry. Does that sound familiar? Okay, right here. So, pick an x value. Pick a nice one so it's not too far away. So maybe like if this were it, I'd put like 1 or -1 and plug that in. Pick a point and then find the y value. Okay. What if my vertex is if my y-intercept is off the grid? So my y-intercept is like way up here. Okay. I'm not going to have that. So what you're going to do is if I have my vertex, okay, and it's going off the grid like this, then what I might do is here's my vertex. Just pick some x values right along here. So if your vertex is this x value, just pick one real close to it. Again, close to the axis of symmetry so you're not going off the grid. Okay, the last one we did was factored form or x-intercept form, and it looks like this. Y is equal to x minus p and x minus q. And of course, if there's an a, it's going to be out here. That's where a always is. Okay? So this is your factored form or your x-intercept form. So what you're going to do is you're going to plot the x-intercepts. To find the x-intercepts are right here. Okay? Just set both of those equal to 0 and solve for p and q, and that's going to give you your x-intercepts. Graph the axis of symmetry, which is halfway between the x-intercepts. So once you plot the x-intercepts, go halfway in between, drawing your axis of symmetry. Okay? So here we go. Here's an x-intercept. Here's an x-intercept. Halfway in between is your axis of symmetry. So that gives you the x value. You're going to plug that x value into my equation, into x values, and find out the y value. So a, p, and q, of course, are numbers. You're going to take your x value, you're going to plug in, because that's your axis of symmetry, plug in that x value, find out the y value. That's going to give you your vertex. Which I just said, use the coordinate of the x axis of symmetry to find the y value. Plot the y-intercept, okay, and to find the y-intercept, all you have to do is plug 0 in for x. Remember? Find the y-intercept, plug 0 in for x. Then graph its reflection, then pick an x value, then find the y value and plot its reflection. Now this last step should sound very familiar. So once you have your vertex, okay, you have your axis of symmetry and its reflection point, oh wow, you might actually be done. Okay, so once you have your x-intercepts, your vertex, and then find your y-intercept and its reflection point, bam, you're done. Okay, so if you need another one, you can pick that. So plot the y-intercept and go from there. So if you need another point, you can do that, but a lot of times you'll already have it. Okay, good. So I hope this is helpful. And let's look at your homework really quick. So your assignment will be found on page 35, and it is graphing in all 3 forms. Okay, so the nice thing about this is that you can use this sheet that I just had, that we just went through, and it's really helpful. And actually this sheet might be helpful if you're a person who can hold on to papers. Hold on to this one. It might be helpful next year in geometry or in Algebra 2 graphing quadratics. Now your teacher will show you great things there too, so don't worry about it if you don't. But so you're going to go to this page, page 35, and you're going to get to graph the different ones. So identify what they are. Then decide what you're going to have. Now in standard form, this is not too helpful right through here. Domain and range, pretty easy stuff. Hopefully stay with that, okay? So domain, just look at your x values. Range, look at your y values. If you haven't figured out already, domain is going to pretty much always be, for this year, negative infinity to infinity. Whereas range, you have to look at what's your y values. Where does it stop? Where does it start? And then it goes on from there. Okay, so your range is going to be the one that's affected. Just identify what these are. Pay attention to it. Now, a lot of times they don't do this, and I don't know why. Always find out what your y-intercept is. That's going to be really helpful. okay, especially on standard form and factored form, is you're going to want to find out what your y-intercept is. It doesn't make as much sense when you're doing it by vertex form. Okay, so just to let you know that. So you're going to be working on page 35 through 36 for your homework. Use this note sheet. Will probably help, but even better if you could do it without this note sheet. That'd be great. Okay, so hopefully that goes well for you. If you have any questions, you know where to find us. Check on Schoology if you're not sure what the actual assignment is, or with your own teacher. Thank you very much.